on to our next talk. This is titled, A Novel MFG-E8 Derived Oligopeptide Protects Against Inflammation and Organ Injury in Neonatal Sepsis. It will be presented by Colleen Nofi.
Good morning. Thank you for the opportunity. My name is Colleen Nofi, and I'm a general surgery resident at Northwell Health, and I'm very excited to present our work on the discovery of a new peptide to reduce inflammation in sepsis. We have a provisional patent submitted, but I have no additional disclosures. My work focuses on two important proteins in sepsis, ECRP and MFG-E8. ECRP, or extracellular cold-inducible RNA binding protein, is a recently discovered alarmin that is elevated in serum and exaggerates inflammation in sepsis. On the other hand, MFG-E8, or milk fat globule epidermal growth factor 8, is an opsonin that actually promotes the clearance of apoptotic cells to reduce inflammation in sepsis. Recently, we discovered MFG-E8 to be a new scavenger of the DAMP ECRP, promoting its clearance and thereby attenuating inflammation in sepsis. However, MFG-E8 is a large, complex glycoprotein whose tertiary structure prohibits its practical use as a therapeutic. Therefore, we embarked on a strategy to develop a new chimeric peptide based on the observed beneficial impact of MFG-E8 to clear ECRP. Specifically, we hypothesized that a novel MFG-E8 derived oligopeptide, herein named MOP3, may replace MFG-E8's function, linking ECRP to phagocytes for removal and thereby ameliorating inflammation in neonatal sepsis. We started by utilizing computational modeling to determine the likely interaction site between ECRP and MFG-E8. We determined that this interaction likely occurred at the discoidin 2 domain of MFG-E8. We then took the known amino acid sequence of the discoidin 2 domain and we fractioned it into 15 amino acid long segments. These were designed to interact with ECRP. We then tagged each of these segments with 3 amino acids RGD, which are known to interact with the integrin receptor. Thus, in this way, the peptide was designed to be a bridge linking ECRP to the integrin receptor. This process yielded 15 potential peptides. Each peptide then underwent in vitro screening experiments, which led to the discovery of MOP3 as the only effective anti-inflammatory drug. We then moved to a preclinical model of abdominal sepsis utilizing cecal slurry. Briefly, we harvested cecal contents and injected them into the peritoneal cavity of 5 to 6-day-old mouse pups. At the time of cecal slurry injection, we additionally treated with either MOP3 or vehicle, and we analyzed for inflammatory parameters after 10 hours. Most importantly, we found that systemic levels of ECRP were significantly reduced with MOP3 treatment, represented in yellow, compared to vehicle after cecal slurry. We then correlated this reduction with a reduction in systemic inflammatory cytokines, TNF-alpha and IL-6, with MOP3 treatment. Finally, we also showed a reduction in tissue injury measured by LDH with MOP3 treatment. So together, these data support that MOP3 reduces systemic levels of ECRP, inflammation, and tissue injury in cecal slurry-induced sepsis. We next looked at lung injury by analyzing mRNA levels of inflammatory markers in the lung. Here you can see a significant reduction in these levels with MOP3 treatment compared to vehicle. Together, this data supports that MOP3 treatment reduces inflammatory parameters in the lung in cecal slurry-induced sepsis. We further looked at pathologic lung injury by performing H&E staining. Here you can see some representative images that highlight the reduction in injury and preservation of lung architecture with MOP3 treatment compared to vehicle after cecal slurry. When we further quantified the degree of lung injury using a validated lung injury score, we demonstrated, again, a significant reduction in lung injury in MOP3 treated mice compared to vehicle. We also looked at degree of apoptosis in these lungs by performing tunnel staining. In the enlarged images, you can better appreciate the degree of apoptosis indicated by green fluorescence, which is significantly reduced in MOP3 treated mice compared to vehicle after cecal slurry. When we quantified the number of tunnel positive cells in the lungs, We further confirmed a significant reduction in apoptosis with MOP3 treatment compared to vehicle after cecal slurry. We finally looked at intestinal injury by analyzing mRNA levels of inflammatory parameters in the small bowel. Here you can see a significant reduction in these levels with MOP3 treatment compared to vehicle. So together, these data support that MOP3 treatment also reduces inflammatory parameters in the intestine in cecal slurry-induced sepsis. In conclusion, we discovered MOP3 as a novel ECRP scavenger that attenuates inflammation and reduces organ injury in neonatal sepsis. This discovery is particularly exciting as it implicates damp clearance through harnessing the inherent phagocytosis pathway as an exciting new target to treat sepsis. Thank you to my mentors at the Feinstein Institute and Division of Pediatric Surgery at Cohen Children's, and I'm happy to take any questions.
This is open for questions, if anyone wants to step up to the microphone. In the meantime, just a question. Have you or are you planning to look at the timing of administration of MOP3 in relation to when you use the cecal slurry? Because obviously we're not treating the patients at the moment that they become septic.
Absolutely. We're currently working on a delayed administration to look at the impact. We also have some planned experiments to look at the stability of this peptide to understand more of its half-life to further guide administration or potentially redosing efforts.
Thank you.
Thank you.
Question?
Hi there. Sorry, Nigel Hall,
Thank
Southampton. Thanks for your presentation. I really enjoyed it. We've seen lots of potential interventions over the years in animal models of sepsis or NEC or similar things that have great potential based on their anti-inflammatory properties generally, but very few of them make it to sort of clinical translation to become useful in the clinic. How realistic is it, do you think, based on your knowledge of this molecule that most of us have never heard of, that pathway could be effectively followed?
Thank you for the question. Unfortunately, this is a harsh reality in a lot of sepsis research. We're hopeful, though, that with continued preclinical studies and improvement in these models, which have shown dramatic improvements in replicating the clinical condition, that they do move forward and we do see an impact. But we know that sepsis research is one of the more highly funded areas, and we still don't have a solution other than source control and supportive care. So we're hopeful that some of these drugs start to make it to our clinical impact, but it is still a challenge.
Thank you.
Thank you.